Hi! So last time is we talk about the Newton's law of motion. And when we talk about the Newton's law of motion, we have three. First one is the law of inertia, on which it states that an object at rest will continue to remain at rest and an object in motion will continue to remain in motion unless acted upon by an external unbalanced force. Next one, we also have the law of interaction, on which it states that in every action, there is an equal and opposite reaction. And for the third one is we have the law of acceleration, on which it states that force is directly proportional to acceleration while mass is inversely proportional to acceleration. And also, we tackled about the different types of forces. We have the applied force, the normal force, the vertical weight, the frictional force, and etc. And for today is we're going to talk about work, power, and energy. So at the end of this session is we will be able to determine, explain, and solve the concepts of work, energy, and power acting and or present in the system. Next one is make connections between work, energy, power, force, and velocity. Next one is identify conservative and non-conservative forces. Explain energy conservation and determine whether or not is applicable before and after the description of the system. Next one is explain and connect work, energy, and power in everyday living. Next one is create a rocket launcher that can propel paper rockets into the air. And lastly, demonstrate how energy, work, and force contribute to projectile motion. Do you know the sport shown in this slide? So I will give you 5 seconds to think of your answer. You're right. So this sport is known as shot put. So it is an Olympic track and field event that has its history back in ancient times when people began to throw or put trucks to display feats of strength. Other than that is that the ball, or known as the shot, which is made up of cast iron, solid steel, or other dense material, weighs about 7.26 kg for men and 4 kg for women. How about this one? Very good. So this sport is known as the discus throw. And for the last one? Very good. So we have here the what we call javelin throw. What if you're going to illustrate or if you're going to demonstrate this sport? First question is, what do you think will you feel after the activity? Second one is that is there something you could have done more to throw the ball or to throw the object even further? And for the third one is what do you think you have just performed? Kindly type your answer on 06 discussion forum. So everything in life is doing something which requires force, which can be in one form or another. So from walking, running, flying, even swimming requires force to move. But what we do not notice is that the force we employ in our everyday life is contributing something that involves more than just motion. So for today is we're going to talk about work and power. Kapag ba narinig nyo yung term na work, ano agad yung unang pumapasok sa isip nyo? So mostly trabaho, minsan opisina, okay? So yun yung karaniwan nating nire-relate sa tinatawag nating work. But in physics, so work is not related to that. It is not related to a job, it is not related to an office, but rather it is an important concept in physics. So the work that we are referring in physics is known as the mechanical work. So what is work in the first place? So when we talk about work, which is expressed in a capital letter W, so it is the action of force moving along a direction. And also, it is the force multiplied by a certain displacement. And we have here the different formulas for in determining the work. So for the first one is, how do we get the work along a straight line? So it is really simple. So work is equals to F, which is the force, times X, which is the displacement. Next one is, how would we determine the work along the x-axis? It would be F times the displacement cosine theta. And for the work along the y-axis, it would be F times the displacement sine theta. Now, we have here the different rules for work. So, paano ba natin masasabi na meron tayong nangyaring work? So, for the first one is that force and motion direction must be the same. So, kung saan mo in-apply yung force mo, syempre, doon din mag-move yung object mo. Halimbawa, tinulak mo yung object papunta sa right, therefore, mag-move yung object mo papunta sa right. Ganun lang po yan. Ibig sabihin, merong work na nangyari doon. Next one is that forces component direction must be the same as the object. So, therefore, kung paano po nag-move ang object nyo, ganun din dapat yung direction ng inyong force. And also, we have here the unit for work, which is joule, which is expressed in a capital letter J or calorie. Now, paano ba nabuo ang unit ng joule? Kadalasan po kasi, di ba, kapag sinabi nating work, ang formula natin dyan ay work is equals to force times the what we call displacement. On which, ano ba yung unit natin for force? It is Newton. Ano ba yung unit natin for the displacement? It is meter. Now, itong joule po na to, it can be Newton meter or J na lang po. Okay? Other than that, so, paano ba natin masasabi na hindi work or hindi nangyari ang tinatawag naman nating work? Tandaan nyo po ito ha, kapag sinasabi nyo pong work, dapat mag-move ang isang bagay. Therefore, kapag hindi gumalaw or kapag hindi po gumalaw ang isang bagay, ibig sabihin wala kang ginawang work. Kumbaga, kahit anong gawin mo dyan, kahit anong i-apply mong force, kahit anong effort yung ibigay mo, kapag hindi siya gumalaw, wala pong work na nangyayari dyan. It is not working. Just, ayan po. Next one. So, force without motion. Just like what I mentioned. So, when a force is exerted on an object which does not move, no work is done on the object. For example, itulak mo man yung pader, hindi gagalaw yan. Oo, nag-apply ka ng force, pero gumalaw ba? Hindi. Ibig sabihin, wala pong force na nangyari doon. Other than that, so when an object is carried at a constant velocity by a force which acts at the right angles to the motion, no work is done on the object. Halimbawa, if you are moving on a constant velocity, then nilift mo yung isang object, ibig sabihin wala ka pa rin in-apply na force dun sa object na yon. So let's proceed to the problem solving involving work. So for the first one is that a fitness instructor is performing a standard push-up exerting a force of 852.6 Newton, resulting in a work done of 255.78 joule. What is the height the man achieves for the push-up? Now, we have here a triangle that shows the formula that we can use in determining the value for the work. Now, ano ba yung mag-given natin sa problem? So, una na po dyan ay yung force natin, which is 852.6 Newton, and ang work naman po natin, which is 255.78 joule. Now, kung hinahanap po ngayon natin ang value ng ating height, ibig sabihin nyo po yung displacement. So, displacement would be work divided by the force. So, just substitute the value for the work natin, which is 255.78 joule, divided by the force, which is 852.6 Newton. So, ang matitirang unit nyo po dyan ay meter. Kasi nga, ang joule natin ay Newton meter. Okay? So, cancel yung Newton. Ang matitira po dyang unit ay 0.3 meter. So, ibig sabihin po, yung height na na-achieved nung instructor natin habang nagpo-push up siya ay 0.3 meter. O, diba? May physics pa rin yun. Kahit nagpo-push up ka lang, makuha mo yung tinatawag natin displacement or yung height. Another one. So, a sailor pulls a boat a distance of 30 meters along a dock using a rope that makes an angle of 25 degrees with the horizontal. How much work is done if he exerts a force of 255 Newton on the rope? Now, dito po is meron na tayong angle na given. Pero tignan niyo po horizontal. Ibig sabihin kapag horizontal along the x-axis. Ibig sabihin po, ang gagamitin po nating formula dyan ay fx cosine theta. Okay, let us just substitute the values natin. So, force po natin dyan ay 255. Ang displacement naman ay 30 meter at ang angle naman po natin ay 25. So, it will be 255 Newton times 30 meter cosine 25. So, the answer that we will have here or that we will get here is 6.93 times 10 raised to 3 joule. That will be the value for the work. So, di ba madali lang siya? Madali lang talagang i-identify yung tinatawag nating or madali lang pong kuhanin yung tinatawag nating work, and also the value of the force, distance, and also the angle. Ayan, so kadalasan, di ba, kapag nagsisimula yung klase, sasabihin ko na, so kindly open all your microphone and say power. Pero ano ba ang tinatawag nating power? Okay, bakit si Kong yun nandito? Ayan, palitan natin. Ayan, so mostly, di ba, kapag sinabi nating power, it involves the movement or it involves something. Kadalasan natin narinig na, uy, ang powerful mo naman. Uy, ang powerful naman ng weightlifter na yon. Uy, ang powerful naman ng car na to. Pero ano ba ang tinatawag nating power on the first place? So, when we talk about power, it is expressed in a capital letter P. So, work done or power refers to the work done within a certain time span. And also, it means that if there is no work, there is no power. Therefore, kung hindi gumalong isang bagay, walang nangyari power dyan. And ano ba yung ginagamit natin na unit for the power? So, the unit for the power is what I call watt. On which, paano po ba yun? So, it is joule per second. Joule per second po ang unit niya na yung watt. So, the other unit for the power natin is we have what we call horsepower, on which 1 horsepower is equivalent to 746 watt. Now, ano ba yung ginagamit natin ngayong formula in determining the power? So, power is equals to work over time. So, ganun lang po siya kadali. So, try na po natin mag-solve ng problem involving power. So, for the first one is a 45 kilogram man is seen walking along the corridor. He is walking at about 50 meters from the entrance, exerting a force of 32 newtons per stride. So, he reached the 50-meter mark in the corridor in under 75 seconds. How much power did he exert? So, syempre, para madali nating makuha yung mga ano natin, kailangan mo nating identify kung ano ba yung mga given natin. So, dito po sa problem na to, dalawa po ang force dyan. So, we have 32 Newton. So, ano ba itong tinatawag natin 32 Newton? Syempre, habang naglalakad siya, yan, so, meron tayong tinatawag kasi dyan na applied force. Ito yung force na in-apply niya. Okay, doon sa nilalakaran niya. So, ito 32 Newton yun. Pero, meron pang isang force na present dyan. Ano kaya yung force na yon? Okay, very good. Ito po yung tinatawag nating weight. And also, the normal force. Alam naman kasi natin na yung normal force equal po yan sa weight. Okay? Other than that, we have the value of the displacement natin, which is 50 meter, and the value of the time, which is 75 seconds. Now, ang hinahanap po natin dyan ay yung power. So, lagay lang po natin dyan. So, P. Then, syempre, hindi mo naman makuha yung power kung wala kang work. Yan, so question mark po yan. So, first thing that we need to do is we need to identify the value of the normal force. Or ito po yung tinatawag, or equivalent din kasi yon sa tinatawag nating weight. Ang kaibahan lang po nila ay yung direction. So, paano po ba yon? So, tandaan niyo po na ang normal force, ayan, so Fn is equivalent to the what we call weight. Now, paano ba natin kinukuha ang tinatawag nating weight? Very good. We're just multiplying the mass of an object by the value of the acceleration due to gravity. So, ganyan po, dahil ang mass natin kanina 45, which is ito. So, 45 kilogram times 9.8 meter per second squared. Ang makuha po natin normal force dyan ay 441 Newton. Therefore, ang dalawang forces po natin dyan ay 32 Newton and 441 Newton. Okay, next one. So, dahil meron tayong dalawang forces dyan, ganito po yung mabubuo niyan. So, tingnan niyo po, ito po yung 32 meters natin, 32 newtons rather, at ito naman po yung 441 newton natin. And as you can see, naka-form po yan ng right angle. On which, kung makita niyo po, itong tinatawag nating hypotenuse, ito po tinatawag natin ngayong resultant. Kapag po sinasabi nating resultant, it is the summation of all the value of the forces present on an object or acting on an object. So, paano ba natin kunin yon? So, we will use the Pythagorean theorem na c squared is equals to a squared plus b squared. So, lagay lang po natin dito, input natin mga values. So, we have the normal force and the applied force. Meron tayong 441 Newton squared plus 32 Newton squared. Next one, so, makuha nyo po dyan is 194,481 plus 1,024. Then, get the square root of the 2, and ang makuha nyo pong sagot for the resultant natin ay 442.16 Newton. So, ito na po yung gagamitin natin ngayon na value ng ating force. Next one, meron na tayong value ng force and meron na din tayong value for the displacement. So, pwede na natin kunin ang work. So, we have here the formula for the work, which is force times the displacement. So, ano ba yung nakuha nating force kanina? So, it is 442.16. Next one is multiply it by the displacement, which is 50 meter. So, we would get the value of the work, which is 22,108 joule. Now, meron na tayong value ng work. Pwede na natin makuha ang value ng ating power. So, ang formula po natin for the power is equals to work divided by the time. So, we have 22,108 joule divided by the time natin, which is 75 seconds. Therefore, the value of the power is 294.77 watt. So, that is the value of the power the man exerted. At kung nakuha po itong sagot na to, kindly unmute your microphone and say power!